Okay, good afternoon. Can everybody hear me okay? All right, my name is Glenn Stevens. I lead Mich Auto. And what Mich Auto is, we are the Association for Michigan's Automotive and Mobility Community. We're based in Detroit, but we work across the state. We also partner with other states and other regions of the world where both the automotive community and the mobility community are existing. We focus real heavily on the talent pipeline, advocating for the industry, but the most important thing is to make sure that we're advancing new technologies wherever they may be in the world. So today, we've got 4 people with us today, and I'm going to let each one of them introduce you. But the way we're going to run this panel is each one of them is going to have a small slide deck to talk about their technology, give you a little bit of thought leadership with regards to this road to autonomy. And then we'll do some Q&A, and I want to make sure that I leave 10 minutes, maybe 15 or so, for you to ask questions too. So with that, I'm going to ask each one of them to introduce themselves and their company, and hopefully our slide decks will work okay. So Phil, please.
Thank you, Glenn, and welcome everyone. I'm Phil Magny, founder and principal of VSI Labs, and I would like to tell you a little bit about our company and give you some kind of the high-level takeaways from our observations. So we are a research company. We practice applied research. We provide research and advisory to companies that are designing, developing, or supplying to either active safety or automated driving technologies. We are able to decompose the entire process from sensor selection all the way through building the AV stack, and we provide a variety of research assets to help companies make smarter and more informed choices. So that's one of our cars there. We are based, our lab is in Minneapolis, but we recently established a company here in Michigan, VSI Labs Michigan, so we are putting our stake in the ground here in Michigan, and we're very excited to be part of this community. I could say that we had a choice. We could have gone to Silicon Valley or we could have gone to Michigan. We chose Michigan because we feel like we can be more effective here. I think we might get lost in all the noise within Silicon Valley. And I'd also like to say, we actually build things. So we have tangible solutions and demonstrations, and it's not just all about the software, but I'll get back to that. So yeah, R&D, we support R&D and planning departments within major companies, OEMs, tier 1 suppliers, component companies. I mean, the diversity of our customer base is really remarkable. It even extends to material companies. They're trying to figure out what types of materials to support the infrastructure necessary to support safety and automation. We're very skilled in the software skills necessary to support this. Of course, this is a lot of programming. We're very familiar with all the programming languages, especially C++ and Python. We also are very experienced with artificial intelligence. And really all of I think the oldest person in our lab is 25. I mean, obviously not me, but I'm kind of old school auto, and a few of us are, but we have a whole group of young people that are thriving within our company. So basically, the way we look at automation, at least within the context of vehicles, land vehicles, specifically those that operate on roads, we really see 3 trajectories for these technologies. One, of course, being the incremental deployment through series production vehicles. So just like as an extension of the passive, then the active safety systems, now you have low-level automated driving features, level 2, level 2 plus. We see that as just huge over the next 20 years as far as really providing the safety, the comfort, and the convenience necessary to support vehicles going forward. Then, of course, we see a lot of development on the robotaxi side. So you're talking level 4. These are driverless vehicles that operate. Of course, several companies, the fleets and the big ride-hailing firms and so forth are developing these simultaneously. And of course, OEMs are really sometimes working in multiple tracks, really, to meet these different trajectories. And then, of course, the third one being really the lower speed fixed route shuttles that are being deployed, that are the very pragmatic deployment of automated vehicle technologies. It's slightly different sensor selection, maybe some different methods used, but the fact of the matter is there's several different tracks for automated vehicle technologies. And then, of course, you go beyond that. You've got trucking, you've got, obviously, agriculture and mining and things like that. It just, you know, extends to just about everything. This is something that we do which has drawn a lot of attention in the industry. We really have decomposed the entire ecosystem of companies that are supplying the different technologies. And this is just with respect to the vehicle. This doesn't even include those on the outside, really. But essentially, these are leading companies. You recognize a lot of these brands. And what we've done is we've lined them up by domain of expertise, really. You can see across the top, it's a little bit hard to read, but you have those that are actually developing vehicles. And again, these are all the OEMs, naturally. And then, of course, a variety of other companies that are building fleets and so forth. And then right below that, you have a whole lineup of companies that supply what we call AV platforms. So those that have a hardware and software stack necessary to support automated driving. So it's really the collection of the compute resources, the software resources necessary to support automated driving. Of course, pretty much all the chip companies have a solution for this, and of course, also many of the tier ones have a solution for this. Then beneath that, you have the different vertical pillars, you know, processing, sensors, data connectivity is a necessary domain. Mapping is huge right now for purposes of automated vehicles. Of course, software and algorithms, that's a whole field in itself. And then safety and security, all the cybersecurity layers necessary to support automated vehicles safely. And then down at the bottom, we have all those that supplies various development tools. So this is kind of a famous infographic. We update it all the time. If you ever want a copy of it, just reach out. This represents a couple of things. First of all, it's our vehicle. We maintain vehicles. We build vehicles for purposes of really understanding how the technologies work. And this chart is very useful because it kind of decomposes really the technologies necessary to support automated vehicle technologies. You know, starting at the top, you have various types of components. You can see in the blue boxes. I won't go through them all, but of course, you have sensors, you have computing, you have localization assets, you have connectivity, you have in-cabin sensing, driver monitoring, occupant monitoring, and so forth. Beneath that, in the middle there in the gray, is really the functions that are performed by those within each domain. And then on the green layer, you've got really the applications that are built around those subdomains. We are exhibiting here. We have our car here. This very car is here, and we can, if you stop by, we'd be happy to share with you everything that we have experienced. And
okay, great. Chris?
That's mine.
Thanks, Phil.
Does everybody hear me? Great. So I'm Chris Posh and responsible for automotive at FLIR Systems, and we make thermal cameras. And I'll start with some facts, and I think you know some of these. There's over 1 million people in the world that are killed by cars. And there's over 1 million deer in the US that are hit by cars. And there's 36,000 pedestrians that are killed by cars. There's about 6,000 people that are killed in cars, and there's 6,000 pedestrians that are killed by cars. And 75% of that is at night. So what's the best sensor to see those pedestrians? On the chart here, I show a current 2018 AEB manual from Toyota. And these are all the things that they say we can't guard against. And we would contend at FLIR that we can address almost all those with a FLIR camera. FLIR cameras have been in automotive for over a decade. They have been used as a driver's aid. In other words, there's a thermal camera in the car, and usually these are expensive cars of the past. And there's a display in the car, for example, a BMW, where there's the thermal camera imaged, and the driver needs to look over, see the image, and then do something to it. they have also cued the headlights of these cars to the analytics that are detecting deer or people. And that's a fantastic application of thermal imaging. Now I'm going to go into just some videos that kind of show our technology. This is not the Uber accident. This is a reenactment of the Uber accident. About a week later, when that pivotal event happened, we went there with visible cameras and thermal cameras and reenacted the event. And this is essentially this is why you'll see in this video why thermal cameras can be so effective at saving people's lives. You'll see a lady walking across the field of view. Already our analytics have detected this lady, and now you're going to see the visible at the very end detect the pedestrian. So we would contend this clearly shows pedestrians and thermal cameras, it's a great match. I have had a lot of customers ask how does a thermal camera do at night in a complex driving environment when there's a lot of pedestrians. It's a lot of clutter. And so I went out and I used a standard visible camera on one side, be on this side obviously, and then a thermal camera on this side. I used the same open source Google SSD neural network, and I ran them on both sensors. On the thermal camera though, I added 14,000 annotated images in thermal of pedestrians and cars, and I think you're going to see pretty spectacular difference between the thermal camera and the visible camera and what can happen. I got very lucky this night because there was this whole huge biking crowd coming down the street, and it really gave spectacular targets. Does this not look compelling to you? For me, it's pretty compelling. We're able to see not only the pedestrians, but we're also able to differentiate if they're riding a bike or not. And we colorize the bikes green and colorize the pedestrians blue. Obviously, the cars are colorized red. We've also done testing in fog. We are fortunate enough to go to Sandia National Labs. They have a fog test tunnel. And we're able, since we make visible cameras, we make near-infrared, long wave, mid wave. We have relationships with LiDAR companies. We're able to reenact what happens in the fog. And then we also do real-life testing. This is nighttime, a very heavy fog night. And you're going to see the visible cameras, because it's actively illuminating the scene at night, has a very difficult time seeing that pedestrian. There's some more pedestrians coming up. But a thermal camera is a completely passive system. We're not illuminating any of these targets. That we just glow at night. And that's why the analytics do quite a good job where we can see those pedestrians quite well in fog environments. At CES last week, I was there, and we released first of its kind self-driving car. This one enabled with thermal technology. It has 10 thermal cameras around the car in addition to your standard suite. And we will prove to the industry why thermal cameras should be on cars and how it will make a self-driving car safer. And specifically for AEB, we'll prove that the current systems where it's visible in LiDAR, you could be much safer if you add a thermal camera. And so what we're doing for this last year is educating the public that thermal cameras are affordable. They're not just a military technology, and they can be used on self-driving cars. They can be used on robotaxis, and they should be used on. You will definitely have a safer self-driving car or AEB technology if you use thermal cameras. This is a picture of our automotive development kit and gives you some description of the different interfaces that we offer. That's all I have.
Great. Thank you. Ryan? Thanks, Chris.
Hi, my name is, everyone hear me okay? My name is Ryan Lewis, and I want to say thanks to Glenn for the invite and the chance to present. This is the first time I've been to the Detroit Auto Show, so it's cool to be here. I work for a company called Inqtel. We are a strategic investor for the US government. Specifically within that, I run a research lab in an applied research domain focused on the intersection of computer vision and remote sensing technologies. And today, very briefly, I'll be talking about a collaboration initiative that we are a part of in concert with Amazon Web Services, Digital Globe, Radiant Solutions, and Intel Corp, called SpaceNet. By show of hands, little audience engagement here. Who here has heard of ImageNet in terms of, I know you guys are loaded, I knew that. All right, so one. All right, so kind of going back to the beginning of when computer vision became popular, right? So we all know, right, computers can classify now images of cats and the breed of cat or dog better than a person. That derived from the ImageNet competition. And so much of open source work in the computer vision community came from that data set. Essentially, what Cosmic and our partners within SpaceNet have created is a similar effort focused on open sourcing remote sensing data. And specifically, why do that? We are focused in the context of auto. We're focused on the foundational mapping challenge. And as you all know, there's a lot of different complexities associated with autonomous or semi-autonomous operations. Our view is specifically targeted on how we can help create a more up-to-date and more accurate base map. So what do? What's essentially a part of this initiative? And it's really 4 things, as you can see here. One is that we open source satellite imagery that is labeled. So to date, we've open sourced imagery from 7 cities. This is imagery provided by Digital Globe. It has, and Todd, correct me if I'm wrong, a little around 700,000 building footprint labels and over 10,000 kilometers of road labels that also have road type and the lane count. We host competitions. We're just wrapping up our 4th right now. And those competitions focus on specific analytic challenges. I'm going to be talking about roads in today's context. We open source all the code from the winning submissions of those competitions. We also, under algorithms, we open source our own baseline algorithms. And as all of you know, there's a lot of complexity around computer vision, particularly when scaling out imagery very rapidly, which is necessary for up-to-date base maps. So we release our own tools to make it easier for either researchers or companies to work not only with the algorithms, but with our data. And so why does this matter? It's something that sometimes gets lost in the discussion about how semi-autonomous operations can work. We view that remote sensing has a very important role, particularly in creating up-to-date base maps. Right? Oftentimes, as we get comfortable with services like Google Maps or Apple Maps or Waze, it's very easy to become complacent with services that are in place. And our view is that as computer vision technologies evolve and mature, in this case very rapidly, it presents a good opportunity to leverage at the same time growing data sets in the remote sensing world to enhance base map information. And we see this occurring in 2 major areas. One is providing up-to-date information on primary and secondary road networks and routes, but then also at the semantic layer, providing or trying to automatically abstract some features, such as road type, number of lanes, and condition of those roads. This pyramid I pulled from a couple of bloggers out of Lyft, but I think it highlights where there's a role for emerging computer vision technologies from a remote sensing perspective. So what does this look like? This is a chart I took from my colleague Adam. Adam, raise your hand, please. There he is. But essentially, his sort of core hypothesis when we were kicking off our 3rd competition was as follows, that most of the computer vision work today, from a remote sensing perspective, is focused on pixel count. And most base mapping services today will do some sort of extraction feature, mainly counting pixels, a road, a not road. And that's great, particularly if you're using certain evaluation metrics. But I think our takeaway was, and Adam had this realization, was that what you really care about most is not pixel count, but you care about the road network. You care about connectivity across different streets, even if there may be obstructions in the way, such as trees or buildings or things to that effect. And so the core question in front of us was, how do we incentivize open source research to move in that direction as opposed to pixel count? And so I'm going to skim over it very briefly, but essentially Adam and the team created a new evaluation metric that essentially layers on a computer vision technique on top of a graph theory technique. So extract the pixel mask, and then on top of that, build your own graph theory network. This allows us to score competitors not on pixel count, but on how complete a road network is, which is really important for a base map. And so what does this look like? Very succinctly, it's the key takeaway here is that in some environments, and what we found in our competition across different cities was that we saw algorithms perform really well in terms of extracting a full network. In other cases, we saw it really struggle, particularly in very complex environments. One of our cities that's in the data set is Khartoum, Sudan. And so not surprisingly, sort of irregular networks, it struggled more with than one of our other cities, such as Las Vegas, Nevada. And so with that, I'll turn over to the next presenter. Hopefully we'll hit some questions.
Great,
if anyone has anything offline, we'll talk more.
Shane?
All right. Thanks, Ryan.
Thank you. Got to get Adam's logo on his slide there.
Yeah.
All right. My name's Shane. I am the Deputy Chief Engineer for American Evolve Motor Technology, and I'm your typical engineer. I took apart all my toys when I was a kid just to see how they ticked, and I really like solving problems, and so that might not be fun for you, but I enjoy it. We have a particularly challenging problem here, the road to autonomy, and so today I just want to talk a little bit about that. But I want to introduce our company. We're just over a year old. And I also want to maybe talk about a couple of questions, key questions. One of them is, where are we? And the second question is, how will we know we're there? And I think these are really important questions. And I honestly haven't heard a lot of talk about it. I've heard lots of questions like, are we there yet? Are we there yet? It's like the kid in the back seat, asking, are we there yet? Not knowing where in the world we are. But I think it's really important for us to understand where we are, and we're going to talk a little bit about that in the short time that we have. So American Evolve Motor Company, or Motor Technology, LLC, was formed just back in 2016. We're here located in Farmington Hills, Michigan, and we are a U.S. subsidiary of Great Wall Motor. So I should tell you a little bit about Great Wall Motor. Great Wall Motor is a privately operated Chinese car manufacturer. Now, they specifically focus on SUVs. They manufacture cars and light truck, but they also are the leading SUV manufacturer for China. And this is really exciting because they produce over 1 million vehicles per year in China and abroad. And actually, our company, American Evolve Motor Technology, is actually collaborating with them on developing autonomous vehicle technology. And we're not just looking at L4, but we're looking at L5, and we're also considering support for L3 as well. And so today, I'd like to maybe lead into a couple of key questions here. And so, so here we are today with the question, where are we? And so I think this is a really fair question. The first question, is maybe we could compare, maybe we could look at what the best in the industry has done to date. So last year, I think here at the big stage over next door, one of our famous AV companies in the community presented results that said, hey, you know what, we've reached less than 1,000 incidents per mile. In fact, per 1,000 miles, to be specific, of actual driving. Now, in fact, they said, hey, this is an improvement from 2016 to 2017. We went from 0.8 incidents per 1,000 miles down to 0.2 incidents per 1,000 miles. Oh, that sounds great. Sounds like we're approaching zero. We're getting closer. And so, I think it's really important to understand, where we are relative to that. And so, first of all, I want to take a step back and look at sort of historical evidence. Where are we at from a human perspective? I mean, if we look at the best drivers in the world, they're here in the U.S., and a lot of that's based on infrastructure and based on the vehicles and population and so forth. But if we look at the statistics, I went all the way back to 2008 because it was easy. It's easy for the public to access. So if you want to access it, you can go back to 2008. NHTSA reports that there's over 5 million traffic incidents that were estimated in 1 year in 2008. And as a result of that, we see that equates to about 2,000 or 1,986 incidents per billion miles. And so when we start to think about this, we go, man, these are really huge numbers. And that's just an incident that includes, both non-fatal and fatal injuries. If we also think about what the result of that is over the almost 3 trillion miles that humans drive, we see that we're at somewhere around 2.3 million injuries per year in that time frame. It hasn't changed much. So we can continue to use these numbers. As far as fatalities, we're talking about 37,261 fatalities in just one single year. So this is pretty staggering. This is the best of the best. And so now we're going to compare that, to our AV drivers, and we got to ask the question, well, we're setting out on this path to drive millions of miles, maybe billions. Is it going to be enough? I think it's a really fair question to ask. So let's maybe look at our best AV provider and compare that to our historical human evidence, the robot versus the human. Where are we? And so if you look at the numbers, if we just take the possible outcomes, the best results that I've seen to date, 0.2 incidents per 1,000 kilometers. Now, we don't talk about what incidents those are, but we can make an assumption for the time being that these 0.2 incidents will be equivalent to a human incident. And that would result in over 200,000 incidents per billion miles if we turned this AV loose right now, according to their numbers. I think we need to pay attention to this, and that potentially could result in maybe 237 million lives lost, and more than 3.7 million. Sorry, the other way around. 237 million injuries and 3.7 million lives lost. We got a problem here, and so what do we do about it?
Day too, right?
Yeah, that's during the day. Forget about night. Yeah, and granted, there's a lot of companies out here, just to be fair, that are doing low speed, autonomy, and they've done this for a reason, because it's a really, really hard problem. So where are we? Well, if I look at where we are from the data right now as a community, as an AV development community, maybe we're about 100 times worse than US drivers. So we got a long way to go, and we're not there yet. How do we get there? So one of the things I think is really interesting is that if you have a destination and you've never been there before, you generally ask somebody how to get there. How do we get there? And they'll say, oh, I've been there before. You can go take this route, turn left here, turn left there. But in this case, nobody's ever produced an autonomous vehicle that drives up to, above 70 miles an hour, can drive at night, as you said, et cetera. Nobody's ever produced this. So who do we ask? Well, all we can do is we can go back to experience on developing other types of systems and say, what are some basic guidelines that we can follow to get there? And so I have a couple of really basic concepts that we at American Haval are really trying to focus on and set as a compass for where we will go in autonomy. And I think that others should be paying attention to this as well. And we actually are going to set some metrics here out on the field and say, is this where we're going? And I'd like to maybe have some feedback from the community. Maybe not today, but at another time we could have some feedback. But so one thing, we have to make this. The system has to be verifiable. So one of the questions is, do we have a verifiable metric? What's the metric? How will we know we're done? We've reached the destination. I think that's important, because if we don't know what the metric is for getting done, or getting to the finish line, or getting to the destination, what will end up happening is we'll wander around aimlessly, perhaps. We won't know how far we are from the destination. In fact, we'll get somewhere and we won't know if we've achieved the destination. And so I think this is a really important question to ask. What is the metric? What defines done? And that's one of the things we're doing at American Haval. I think one thing that can help us is foresight. And not to add a tag for your partner company there, but if you don't know, Foresight's a stereo imaging company that I think use FLIR as well.
Thermal and visible.
Yeah.
So dual stereo.
Yeah. So anyhow, but I think when we look back, we always say these things like, "Hey, hindsight is 20/20." We need to have foresights that's 20/10. It needs to be better than that, because we got people's lives at stake here. So I think it's really important to think about, how can we make this foreseeable? And honestly, if we think about the complexity of the problem, we can say, well, let's test every possible combination. Well, in fact, it's not possible to do that. It's humanly impossible to do that. If we took all the resources in the world and spread them apart, over all of time, we would never test every possible combination of situation that would come up. And therefore, we need to come up with an equivalence metric, a way to measure this that would say, hey, it's equivalent to a human. And so I want to propose as an acceptability criteria that we need to be better than a human. In order to make this system work, we need to have something that says, hey, public, are you going to accept our autonomous vehicles? Well, if you are, you're probably going to say, well, is it better than human? And the general public's going to say, no, it's not. It's 100 times worse right now, so I'm not going to accept it. So we got to make it better. And equal may not even be enough. So I want to propose a metric that says something like this. 200 billion incidents, or sorry, not 200 billion. That'd be more like what we'd get. 200 incidents per billion miles, or far less than 1 incident per trillion miles. This is how big the problem is. Less than 1 incident per trillion miles. And I want to say it's an equivalence. It can't be an exact, let's go out and drive 1 trillion miles. We need to find a way to see what's going to happen in the future and capture that back in our testing and actually show that and actually spread that across the community. Not just American Evolve Motor Company, Great Wall Motors, but we need to look across the entire industry that's developing AVs and say, how do we put a metric out there that everybody can meet, so that we can actually do something that I think is really amazing if we look at the numbers. And before we go to that, real quick, hey, something from the perspective of lives lost, I think the World Health Organization has mentioned that, and that by 2030, that traffic-related deaths will be the 5th leading cause of fatality, and this will surpass heart disease, lung cancer, and stomach cancer. I mean, this is a serious incident. We need to solve this. And just to finish this up, Glenn, if we were to get down to
we can't tell you're passionate about this.
If we were to get down to 0.2 incidents total, including both non-fatal and fatal, that would allow us to save or reduce the number of injuries in the U.S. by over 2 million, and over 45 million globally. And furthermore, if we could reduce this down to 0.2 incidents per trillion miles, we would get to we would save 27,000 lives or more in the U.S. with the potential to save over 1 million lives globally. And so I think, for us, we want to understand this metric a little better. We want to dig down and figure out what that decomposes into. But this is the beginning of something, and I hope that the community is thinking about something very similar. So thank you.
Great, thank you. I don't know about you, but the best drivers in the world are not on my commute. I don't know where you're driving in Detroit, but I want to know.
Well, yeah, fair enough.
So, thank you all. I mean, the purpose of these panels is, we wanted you to all hear from these companies because they're all new. I mean, none of you were around 10 years ago, certainly.
FLIR's been around for
FLIR
40 years.
But most of you are brand new companies, 1 year old or adapted, right? So you're part of the ecosystem in a new way. But I'm going to touch on one thing. We got about 10 minutes, and I'd like to try and catch one from the audience. 3 of the 4 of you mentioned open source. And I'd like to get your opinion. That's newer to the traditional manufacturing space, but it's certainly prevalent. And we've certainly seen some incredible technological marvels come out of open source. Talk about that role. We'll start right here and talk about the role of that in this road.
Yeah, as it relates to most mapping activities that we see today, whether it's from a large incumbent supplier or a new startup, almost all of their work is at least founded in some of the open source frameworks for computer vision, whether they're working off a TensorFlow API or some other service. And I think the key thing to understand is you're either looking at companies that you're interested in partnering with or wanting to build your own work organically, is figuring out where in the stack you want to build on top of. And essentially, how much are you going to rely upon some open source efforts, and where do you begin your custom software development? I think why do we do what we do in terms of our competitions as it relates to roads in this case, it's best to be thought of as a good primer to get started. but honestly, some of the best work gets done really at that application layer. So what would be really exciting to see is for companies to say, I'm necessarily not going to build my algorithm from scratch, because that's an extremely laborious activity, but say maybe take some cues from what I've seen from different open source competitors and maybe modify something like that to get an early product out the door.
Does anyone else have a quick comment on this?
I do.
Yeah, please.
FLIR's motto is to save lives and livelihoods. And when we saw the capability of thermal imaging for self-driving cars, we went through the expense of annotating a bunch of videos in thermal, because most people have our visible data. They have annotated visible data. And so we said, well, the industry is missing something. So we annotated a large data set and at a big cost. And we made it open source. We put it on our web. Anybody can go download it right now, and they can take a thermal camera, anybody's thermal camera, and they can take our data set, and then they can put two together in a convolutional neural network, and they can see what thermal does. So yeah, we believe in open source and getting the word out.
Seems like the synergy's there.
Yeah, I was just going to add, and we've even experienced that, Chris, that training set, and within a relatively short amount of time, we were able to create some amazing results using that training set. So, yeah, I mean, open source is hugely beneficial to the development of what's happening in this space. I mean, a lot of the development begins there because there's a lot out there. Now, whether or not ultimately some of these alliances get traction, I think is yet to be determined, like AutoWare out of Japan or Apollo out of China. I don't know, they're getting a lot of great members, and a lot of people are developing around those open source assets that are out there. So it's, in my opinion, it's really helped kind of accelerate the development.
Shane?
Yeah, I just want to say too, I mean, I think there's, in fact, we started with open source as well, and I think it's really probably an important part, just like AI, but I think there's something here that's really important, whether it's AI or open source or, an algorithm that you developed. We can't dismiss the fact that we have to be able to understand what it is. We have to be able to explain it to the community, to, eventually for litigation. And we have to be able to test it and verify that that the function actually works. And I think that's what's really important. It's not so much where the source comes from, but how will we actually validate that this thing is robust and safe and so forth.
Well, let me ask you another big picture question. On this road race competition, a lot of people don't like that word competition. I've heard some new names with regards to who's kind of out at the forefront on that top line that you said. So just kind of your opinion about who's leading, who's advancing. Why don't we come right down the line?
All right. Well, regarding the question, we're there yet. It all depends on what you define as there. Are you talking level 4, level 5? The way I look at it, I mean, within series production, level 2 plus is alive and well, and that's going to be hugely important with respect to sales of series production vehicles over the next 10, 20 years. There's a variety of level 2 solutions out there. Some are level 2 plus, which improves the safety and the performance of these systems. They're getting better and better. They're collecting data. The algorithms are refreshed and pushed back out to the cars. Where you run into problems with level 2 is you get a lot of misuse out there, and that's a very difficult thing to control. But the technologies are there. There's this level 2 plus thing. A lot of people talking about that at CES. It's bringing some additional software assets into that vehicle to improve the performance, and specifically localization assets in particular. That's of course mapping, and that's all the metadata associated with the roads. And of course that's localization assets too, depending on whether you're doing point cloud or object or landmark based. There's a lot of different methods, but that substantially improves the safety envelope within the context of level 2. On the level 4 stuff, I don't want to get carried away on that, but yes, the whole fleet movement. There's just a lot of new players in there, and of course the ride-hailing companies, and yeah, I mean they're making great progress. They're not quite there yet, but I think within a couple of years, yeah, you'll see these deployments in a very constrained way, I might add. I mean, they're not going to be roaming freely around these cities, but they're going to be their operational design domain will be very, very specific to a certain road, perhaps a certain lane, certain time of day, and so on.
Well, Shane, in addition to Great Wall, who else is leading?
Well, yeah. So actually, I think we have some really great opportunities at Great Wall as well, and they're a young company. They've only really been producing public transportation for about 15 years, and I think they have a huge opportunity just from the perspective of their background. But in addition to that, I think there's some interesting leaders out there, and we're depending on whether you're talking about investment or you're talking about capability. If you started with Waymo, obviously there are clear leaders out there from the perspective of an L4, fully autonomous, full L4 capability for all speeds. But on the other hand, there's this subject that nobody likes to talk about, a company called Tesla. And I actually think they're actually out in the forefront, and everybody wants to ignore them because they're sort of the cavalier company that's come out of the dark and come into the light and is sort of disrupting some things. And so from a perspective of data collected, I mean, let's talk about that for a second. Tesla has collected over 1 billion miles of automated data. That is amazing. Waymo, 10 million. Okay, so those are the two leaders as far as I'm concerned. I would think that Cruise Automation would be following with GM. They're into the millions of miles as well. But and I mean, we could talk about all different subjects here, but I'll just tell you this: is that at the end of the day, somebody has to validate this, and it's really hard to collect the data. And so when I look at the equation, I say, well, how do we get the data? And there's companies out there that are collecting the data, and it's probably one of the most important pieces that exists in the puzzle. And it takes a long time to get the data. So don't start now and expect you're going to have it done tomorrow.
Chris, Tess?
Who's the leader? I can't comment on that.
Well, I mean, you're true.
What I can comment is that from last year to this year, it's been an amazing ride, and it's been quite interesting to see people realize the value of thermal and start to understand the value of thermal and realizing that this is an incredibly complex problem. Yeah. And just driving during the day is hard, but now I got to expand that and add redundancy. How do I do that? And that's where I'm super passionate about explaining them the value of thermal imaging.
Thanks. Brian, any last thoughts on that?
Yeah, really succinctly for mapping, obviously there's a lot of very strong incumbent providers. I think where we're seeing some of the most activity, whether it's a venture-backed startup or just early-stage companies, or companies that are offering very niche services. So companies that are building out, in this case, road networks or foundational map information in areas that are classically underserved or don't have a strong telemetric data historically. Those are really interesting, and from our view, it's curious to see if they'll continue to operate independently as a specialized feature or eventually make their way into one of the large mapping services like Google Maps, Apple Maps, or here.
Okay. We've got time for one question. I know it's only one, but does anybody have anything that... Yeah, please. We'll do one right here. We'll wrap it up with that.
It seems like in terms of the existing data projections we hear or estimations that we hear, there's a lot of incredible extrapolation from very little data. I'm relieved to hear you talk about some very sobering numbers because I've heard a lot of people saying we're already nearing parity in terms of the safety for autonomous vehicles. How do you manage grossly exaggerated expectations, which I think is what's out there today?
Well, we've got a couple minutes, so who wants to take that one first, and we'll wrap it up with that. Shane, I see you itching.
Man, I think I could talk for the rest of the week on grossly.
Well, how about a minute and 37 seconds?
A minute and 30 seconds. I'll do less than that, but I think that we really have to understand where it is we're going, and I think we have to really understand that from I mean the reason I presented this stuff today was, it is truly sobering to look at the numbers and go, maybe we're not there yet, and how do we get there? And better yet, how do we get there as a community? Because all of us are trying to get there. There's probably been over almost $100 billion invested in autonomy, maybe more, and just in the past several years. And we're going to make that investment pay off. How do we work on this together? I think that's a really important point. I think that's what we need to do. We need to find partners that really want to work together, not just, everybody wants to, can you give me money and I'll work on it? We need to actually get together and say, hey, look, I don't have any money to give you. And vice versa. Let's work on this together. We have the same problems, and let's put together a standard, and let's meet that standard, and then let's improve each other's lives.
Great. Last thoughts, right?
And I would say why host competitions and why standardize the evaluation metric, particularly in the case of routing, is because it allows, at least for, even in a small way, a verifiable way to measure performance against either companies or research labs.
Well, please join me in thanking the panel for their presentations and discussion today. Thanks, guys. Appreciate it. Have a good afternoon, everyone.
Thanks a lot.